It's my pleasure to be welcoming the first keynote speaker of this session. He is the SVP and the Chief Technology Officer and Senior Vice President of Research and Development at Seagate Technology, responsible for all hard disk drive product and component research and development. Prior to his appointment as CTO in 2013, this guest of honor held many different roles within Seagate. Please put your hands together to welcome Mark Ray, who comes in from a very, very different time zone, but apparently is used to many zones because of his constant travel. In fact, his prior assignment, one of those was also at IBM, and I'm told that during his tenure there, he was named an IBM Distinguished Engineer in 1997. Clearly, we are a distinguished company, and we look forward to the keynote address given by Mark Ray. Over to you, Mark.
Thank you very much. It's a nice introduction. I should have invited my family. I want to thank the IESA organizers for inviting me to this. It's quite an honor to be here. What I'd like to talk to you a little bit about this morning is, we heard a lot of great things earlier in the day about all the amazing initiatives that are happening for Digital India. So I want to talk about, not just all the data that's generated, but how do we store it and use it? Okay, so a couple messages that I hope you end up taking away with today. First is that data is being generated at just a phenomenal rate. And we'll show you a little bit about that. And I think you all know that just from your daily experiences. The other thing is that the value of data is incredibly high. So, there's statistics that show the company who actually use their data, be it for marketing or analyzing their manufacturing processes, really return better investments to the shareholders. And there's a huge opportunity for determining how, as India becomes more and more digitized, how that data is stored and used and what devices are being used to store it. And then lastly, just about Seagate, some of you might not know, but I'd like to show you a little bit about our range of products and how we fit into this infrastructure to support Digital India. And hopefully you'll get the sense that we're extremely innovative, we have great people, we have a huge product scope, going from the fastest data storage devices and PCIe accelerator cards to archive hard drive systems, and that we have huge manufacturing scale to be able to accomplish some of these huge tasks that are before us. So first on the agenda, let's talk a little bit about data trends. And there's a million statistics about how much data is used and being generated. And this chart just shows some things that might happen in an internet minute. So 300 hours of video get loaded up to YouTube every minute. Over 4 million people respond on Facebook. Well over 4 million do a Google search in a minute. So just huge amounts of data. But I think it's a little bit easier to get the sense for this with the picture. So here's a photograph of when Pope Benedict was installed at the Vatican in 2015. So just a little bit, or 2005 rather, a little bit over 10 years ago. And then here's a photo in 2013 when Pope Francis was installed. And I think you can tell that just in that short time, less than a decade, there's a huge amount of mobile devices. And I see a bunch of them out there today. So, where people are creating content, sharing content, looking at data and content, and communicating in a social way. So this in itself just generates a huge amount of data. So, as we mentioned, the data sources are increasing, and we showed one there with mobile devices and consumers using social media in different ways. We heard a little bit this morning about the Internet of Things and how that is growing. Many devices are having different ways to communicate with each other. So there's a lot of machine-to-machine communication. I actually recently heard about some light bulbs that actually are connected to the internet and transmit data. And maybe we could have used one this morning to transmit a little data. But it's just an amazing amount of ways that data is being created, and people are finding different ways to use it. So as I mentioned, big data analytics is an extremely important vehicle for analyzing trends, be it market trends, healthcare trends, or genomics, weather trends to look at climate change and the like. But with all the data that's being collected, people are finding ever more ways to use it. And another important thing that we probably won't touch on here, but it's the security of the data. As we get more and more personal data loaded, people obviously want to feel secure about it. So that's a whole other topic in itself that I won't be touching on today. But some of the facts that we mentioned, companies who use big data are twice as likely to be in the top 25% of financially performing companies. So there clearly is a value that one can deliver to shareholders or the particular research project that you're running. Let's look at some growth about just how big this big data is. So there's a bunch of numbers on here. Basically, if you look out at the end of the decade, predictions by IDC and others would assume that 44 zettabytes will be the amount of data that's created. So a zettabyte is 10 to the 21 bytes, those who are keeping score. And you might hear some words like exabyte in the talk too, which is 10 to the 18. And there could be a quiz later on what comes after zettabytes. You can get your mobile device to look it up while I'm talking. The amount of data that will need to be stored is about 13 zettabytes. But the amount of data that an industry, worldwide industry, be it hard drives, tape, optical, solid state devices, is going to be able to store is about 6.5 zettabytes. So obviously there's a gap, and that's one reason that we need to be smart about how we use and store the data and what kind of devices and what's the best way to gain all this value that we'll get from it. Because we're having explosive growth in the data as we've seen, but IT budgets are not growing at the same level. And I think that will be very important as India becomes more digitized, and that we have to be very smart on how we use our dollars to get the right amount of storage. And there's also an interesting shift in data that's happening. So if you look back at the start of this decade, about 2/3 of the data was shipped into the client market. So that would mean like your laptop or your desktop or something where the data was locally resided with the client. Now if we shift to 2020, at the end of the decade, see there's basically been a shift where close to 60% of the data will be stored in the cloud. And only about a third of the data that's generated will still be stored on client devices or close to you. You also see growth in consumer electronics, so like digital video recorders, games and the like, and then smartphones and tablets. So the hundreds of millions of devices will account for some small sliver of that data. But you can see the vast amount of data being stored is on solid state and hard disk drives, majority of that in hard disk drives, and the majority of that is moving to the cloud. This becomes extremely important for this really bold concept that we talked a little bit about this morning, Digital India. So this is, I think, truly a visionary idea that's combining a lot of the digital collection of data and use of data from various government ministries and the like, and departments, and really trying to act as an umbrella organization to look at, or corral all these different initiatives that were talked about this morning, like the broadband highway or personal data, as we talked about, and being able to communicate financially different transactions. So all these various initiatives that are happening are in this umbrella organization of Digital India. And as I said, I think this really is a visionary idea, and it's a hugely complex idea. So first, from a technology perspective, being able to store this amount of data is a huge technical problem. It's got some really cool stuff happening though, so that's fun from an R&D point of view. It's also a huge scale problem. So being able to scale, this large amount of data that will be collected and used in a cost-effective way is another huge challenge. And that's really what I want to talk about for the rest of the talk today. So let's talk about applications. So there's lots of ways to store data, and I think a lot of you know that. You can have things that are very fast, but usually they are very expensive. Or you can have things that are not as quick, but come at a lower cost per terabyte. So this is the way that, or kind of the premise of what I want to talk about is that you really need the right kind of infrastructure for the right kind of workload to be able to deliver a system that will give the user the experience that they want to, but at a cost-effective way. So it's kind of a few axes that we might want to look at. Maybe this is hard to see in the back, but I'll try to describe it. So along the y-axis, there could be a performance parameter. There's a cost parameter along the x-axis, and then going into the page, maybe a power parameter. And all the different types of data that you might use, be it flash or hard drives or some combination thereof, kind of go into a different part of this curve. And depending on the application, you might want to use different amounts of flash or hard drives. So kind of up in that top, that big red ball would be online transaction processing. So that obviously you want something very fast, especially if you're a financial institution. You might not be as dependent on cost, and you probably can deal with some power. So in an installation like that, 10% or so of the storage that you use might be solid state. On the other hand, if you go kind of to the other end of the spectrum with something like archive, that one is going to be more power and more cost sensitive. So there you might want to use more hard disk drives. So depending on the type of workload, and there's clearly going to be lots of different workloads in the Digital India scenario, you're going to have to optimize your data center to deal with these different amounts of data that's being used, generated, stored, and then you have to also consider the cost of power associated with those. So, another way of looking at that, from mobile applications all the way through the transaction processing, as I talked about, or just a generic kind of data repository like Facebook or someone might have, through to the big data where we're analyzing all these different amounts of data, and then to high performance compute, which we'll talk a little bit more about later. You're going to have extremely different workloads, and you're going to want to optimize your systems in different ways. This is an exciting time for the exciting time for architects in this business on how you do this. As I mentioned, back in the old days, it was really just you had your client compute, and then there was some enterprise data centers. So you'd have your PC, and the banks would have their data center, or the airlines or government agencies, but there really wasn't much in between. And today, there's just an explosion of different kinds of data that's generated and different ways that people are using it. We still have some of the ones that we mentioned about in the past, the personal and enterprise space, but there's also transaction processing. Surveillance is a huge application. That was mentioned a little bit in the smart cities, the video. And even at today's rate of video penetration into surveillance and the like, we generate about 550 petabytes of data a day with the video installations that are installed for surveillance. You might not have a good sense of what that is, but that's 11 million Blu-ray discs a day are generated just from the installed base that is happening today with surveillance, which certainly is expanding daily. Let's look at one little example here, the high-performance compute. So I think this is a fun example to look at. We like it from a technology perspective because, like in the race car, you put a lot of your point of the spear technologies, your really leading edge stuff into high performance compute. So it's great from a technology perspective where you get to develop this and then flow it down into other applications as time goes on, which helps improve performance, increase the capacity, and reduce cost. Another good reason to look at high performance compute is its storage itself is really the fastest growing space in the HCP arena. So maybe again a little bit hard to see, but storage was growing at about 10% through the rest of this decade, whereas the server part would be growing at about 8%. So it's clearly important, as I said, people value data, and the ability to ingest the data into an HPC system and get it back off so you can do all the data analysis is extremely important. there is going to be well, Seagate lights this not just for the growth, but our cluster store system, which is a specifically designed HPC rack system, is in 7 of the 10 largest supercomputers in the world. So this is, as I said, a space that is very close to our heart, and some place that we like to keep working on. There will be a HPC panel discussion, I believe, tomorrow. So if you're interested in this, just a little bit of an advertisement for that session. Okay, so let's look at some of the storage challenges and opportunities. And I'm assuming some of you haven't had a look at a hard drive like this. If you did, you probably violated the warranty. But let me just go through some of the technologies that are in there, because it's really phenomenal amounts of technology at very, very low cost. So first is, let's look at the recording head. And this is a transducer that takes the electrical signal, converts it into magnetic field, so you can write the data on the disk, and then also has the read transducer, which senses the magnetic fields coming off the disk and converts it back into data for you. So these are made using semiconductor-like processing technologies, lower temperatures. We do more PVD kind of depositions, less diffusions, and things like that. But still, advanced photolithographic techniques and the like. And it's an extremely complicated device. We have about 90 mask layers in this device. There's about 100,000 devices that we make on a wafer. Our wafers are a little funky. They're not silicon. They're a kind of ceramic. But again, incredible amount of technology goes into this device. It's able to write data, and I'll show you in a little bit, sub 100 nanometer kind of track dimensions, and can get the data off the disk at over 2.5 gigabytes per second. The disk also flies amazingly close, or the head flies amazingly close to the disk, and I'll show you that in a minute, a little bit. But we're talking about less than nanometers away from the disk. Let's talk about the disk. That's the shiny thing that actually stores the data. Again, a phenomenal surface. It's certainly the smoothest mass-produced surface on Earth. NASA, the U.S. Space Agency, is putting a new telescope into orbit, and the collection device, the mirror on that $20 million, how much ever it is, optical telescope, is about 10 times more rough than the surface of this disk, and we make about 100 million of these a quarter just at Seagate. There's also phenomenal tracking. So you have to be within nanometers positioning of the head on the tracks to be able to get the data out. And there's a lot of electronics involved in this. So there's multiple microprocessors. We have some very complex SoCs and channel technologies. There's also a lot of software. There's about 2 million lines of code on each disk that you get. So you can have all this amazing technology for extremely low cost. Let's just look a little bit at some of the dimensions. So at the areal densities on our most advanced product that we're shipping today, which is 1 terabyte per platter in a 2.5-inch disk, or 2 terabytes in a 7 millimeter thick hard drive. The track dimensions, as you can kind of see there, are about 40 nanometers in the track dimension and about 11 nanometers in the bit dimension. So we're able to kind of exceed the photolithographic limit in the linear dimension at 11 nanometers because we're using the gradients of magnetic field to define the data. The track dimension is more defined photolithographically, so that we're in the range of what moderately advanced semiconductors are today. And then the spacing. So if we look at some normal things you might see, so human hair is about 100 microns in dimension. A smoke particle, if you go take a break outside, it's about 6 microns. Smog particle, if you've been to Beijing lately, it's about 2.5 microns. But we're flying less than a nanometer above the surface of the disk, and we actually actuate the head down thermally to get within a few angstroms. So again, phenomenal kinds of technologies that are in this extremely low-cost device. And we do have a roadmap going forward, so we're not going to be done. As we work through the Digital India project, there'll be many, many years of technologies. Let's just look at a couple of those real quick. So Seagate recently announced a 10 terabyte nearline or enterprise class drive that actually we've sealed this drive in a helium environment. And that's so as the disk is spinning, there's less air turbulence, so it generates less heat, less power, but it also keeps the mechanical positioning of the head and disk reduced because of less turbulence. I think one of our more fun technologies that I'd like to talk to you about, where Seagate is certainly a global leader, is something called heat-assisted magnetic recording. So what the idea here is that we make the bits smaller and smaller on the disk. At some point, they will become thermally unstable. So we have to make the media that we're writing it on very, very hard to write. And it's so hard to write that we can't generate enough magnetic field to write the way we used to. So the concept is that we would heat the disk using a laser. Oops, sorry about that. See if the video works. So we heat the disk using a laser, and you can see a little semiconductor laser attached to the top of the recording head. The video's not working. Let me go back again and see what. If you don't click on it, it should work. Don't click on it. There we go. Okay. So we put a little semiconductor laser on the head. We channel the laser light with an integrated waveguide and focus it onto a small gold antenna. So the laser light, the electric field from that, generates something called surface plasmons, which re-radiate into the head. And we can focus this light well below the diffraction limit. So what you're seeing in the video, that little bright spot on there, is the recording head moving along the disk and heating up the material on the disk. It heats it up to about 800 degrees Kelvin and cools it off back to room temperature all in about a nanosecond. So again, to be quite honest, I don't think anyone understands the physics of how this works, but we are getting the device to work. We're at areal densities above where we are with conventional perpendicular today. Just to give you, again, a little sense of what some of these numbers are like. So that thermal gradient of heating up the material, in this very small spot, something on the order of tens of nanometers, and then cooling it off. So heating it up to 800 C, cooling it off to back to room temperature in a nanosecond. That temperature gradient, if you were to take an ice cube, wrap it in a sheet of paper, and put it on the sun, it wouldn't melt with that kind of thermal gradient. So again, just incredible sorts of physical phenomena is going on these readily accessible devices. One more area that I talked to, again, based on the performance of the drive, is things that we're doing with caching schemes and also with just other features that we put in the drive, specifically designing a drive for high-performance compute. We showed this drive, and then in the Seagate Cluster Store product at the recent supercomputer conference in Austin, Texas, just end of last year. And it gives huge performance boost to the drive. Why this is important is, hard drives, as we say, are low cost but not very fast, whereas SSDs and other solid-state technologies are much higher performance but higher cost. And there's a fairly broad range of performance options in there that we really can't access. So we're specifically trying to design drives and systems that would address this mid-space. Again, trying to address projects like a Digital India that are going to require a huge amount of data to be ingested and read in a very fast way. So I talked about ways that we're increasing areal density, and this was, I'm sure more people are here are familiar with solid-state memories. So again, as the solid-state devices have had a roadmap to go from two-dimensional until we scale things where there's, we're running out of electrons to count, to three-dimensional, which adds some process technology, but obviously increases the capacity of a chip, to maybe new technologies. There's a progression and a roadmap. And the hard disk drive industry does the same thing, shipping what we call today shingle technology to something called two-dimensional recording, where we look at multiple readers and maybe even multi-dimension codes, and then to the heat-assisted magnetic recording that I just mentioned. So a little bit about Seagate. Seagate's over 35 years old, and we've been really a hard drive company for a lot of that. But through some acquisitions, we've entered more into the flash controller state with LSI Avago acquisition, and the system state where we're making racks and delivering those. So again, we're trying to broaden our product portfolio as we see that there are these various applications that I've talked about. We also have a global presence, about 55,000 employees worldwide. Here in India, we have 3 sites, 2 design centers in Pune and Bangalore. So again, Seagate has a global presence and the scale to deliver these kind of solutions. We make about 45 million disk drives a quarter. We take in over 30 million parts a day. And we have been honored by Gartner for various supply chain awards, because this does get pretty complicated with the complexity of the technology and the scale of the business. And as I mentioned, we're really trying to address all the markets, from silicon controllers through storage devices and hard drives and solid state drives, and then through systems and solutions there. So as I mentioned, there's a broad range of portfolios or products that you would need in your portfolio to deliver cost-effective but high-performing solution like Digital India will require. On the high end of that scale, the PCIe accelerator cards are some of the fastest in the world. We have customers ranging from financial institutions to government agencies and other people who need to get data in and out quickly. Those devices are actually designed here in India and tested here. And then going all the way to the other end, archive kind of hard drives. And as I mentioned, there's a broad range of applications in the middle. And this is where we're trying to optimize the performance that's needed in a system to the cost that's required with constrained IT budgets. And you can see we can really address any space that one needs in that range of performance and cost. So just trying to sum up, hopefully you got a sense that there's an amazing amount of technology, plus a huge scale. So delivering, lots of products all over the world. As I mentioned, we're rated the 20 best supply chain company in the world by Gartner. We make a lot of controllers, so 12 million flash controllers, going to state-of-the-art semiconductor kind of dimensions with leading-edge tolerances and line widths there. Also, the scope of the projects are really complex. It's kind of funny. Drives use 51 elements of the periodic table. Bosses always accuse me of trying to shove more in there, but that's not necessarily what we're trying to do. It's just there are specialized materials that you need. We're going with very advanced and low-cost kind of flash devices, moving from SLC to TLC, and trying to increase the reliability and performance of all those devices. And I think, to deliver something like this, you also need to be fairly innovative. We've been recognized by Thomson Reuters as one of the top 100 global innovators for 3 or 4 years in a row now. We've got over 9,000 patents as a company. And we're really trying to, push the edges on all areas, be it, performance, cost, power, reliability. Wherever there is a market, and I think what I was trying to motivate was there's markets in all these areas. We do research and innovate in all these different spaces. So to sum up, I hope you got a sense that data is really being generated at huge rates. It's extremely valuable, as we can see from all the companies who want to get your data for marketing purposes, or all the different scientific applications, medical applications, and different security applications that happen. You have to be smart in how you manage and use your data, and Seagate as a company can do it. So let me just thank you for your patience and time, and I appreciate the opportunity to talk to you.
That was a key keynote speaker, the first of this session. Thank you so much, Dr. Mark Ray, for telling us about the storage for Digital India. And so interestingly, I request Mr. Jaswinder Ahuja, Corporate VP Cadence, who significantly is on the IESA Executive Council, to please hand over a memento as a token of gratitude for our keynote speaker.